Hi everyone, this is a new video. In this video, we will talk about how we can actually train our model to act better since we got in our previous video the prediction of 0.58 and 0.48. So for example, given the true labels here as 1 and 0, so we got the right label which is 1 which is plus 0. Need to update the model weights to make the model act better. So what happens mathematically inside? So first of all, we pick a certain loss function. For this type of problem, if we have a softmax gives us probabilities. So the best loss function to use here is cross entropy. Why? Because it works very well with probabilities. We will see now. So in this loss function, it is a summation, okay, for from 0 to c, from 0 to all the classes we have, for yi, which is the true, and this is the predicted. Okay, so it will be negative yi is negative 1 times len y predicted is 0.58, okay, plus 0 times len 0.42, which will be 0. Okay, so what happens here? If this value is 1, we will get a loss of 0, which means our model is perfect. Highest probability is 1 actually. So why do we have a negative here? Because any value less than 1 for the len will be a negative value, and we want to normalize the values from 0 to positive. 0 indicating the least loss, and more than 0 indicating that we have a loss. More than 1, of course, it's a very bad loss. Okay, so we can use this loss value, which will be here upon calculating it will be around 0.52. So this is our loss value. We use it as a stopping criteria to stop training the model, for example. So how can we actually update our weights? We need to minimize the loss. This value, we need to minimize it. How we can minimize it? So we need to minimize the loss with respect to our output. Okay, so we do not have a formula that have both, so we can get the derivative out of it. So the loss here is the cross entropy. So how can we actually get AL by AZI? We will use the chain rule. So here we have the loss, so we will get simply AL by AY hat times AY hat by AZI from the softmax function. So this way we can get and minimize the loss. We will go through driving this formula in another video because it will take a lot of time, but upon getting the formula you will find that to minimize the loss or the loss minimization with respect to the output, it's actually y predicted minus y2. So in our case, we have the y predicted for the first one as 0.58 minus y2, which is 1, which will be negative 0.42. And for the other one, it was 0.42 minus 0, which 0.422. So this is our vector for minimizing the loss. This is our vector, negative 0.42 and 0.42. So how we actually can update the weights? We got the vector to minimize the loss, but we need to apply it to the weights actually. So we need to minimize the loss with respect to weights. So getting the derivative or the gradient is actually minimizing the function. But we do not have a formula for both of them too. So what can we actually do? We will do the following chain rule again. AL by AZI times AZI by AW. This is from our original function, which is Z equal WX plus P. So getting the derivative of it, X is like a constant here, so it will be X. This is its derivative, and we got the derivative of this as y hat minus y2, which is this vector. So we should have the vector of X, and we have now the vector of y hat minus y2. So I did the calculation in order to not to make the video very long. We have the weight the original weights, and to update the weights we do the following. It's weight new equal the previous weight minus learning rate times AL by AW. So how can we actually get AL by AW? As I said, it will be simply y hat vector minus y true times x, which is our input from the previous video. And upon doing this, you will get this matrix. And the learning rate, you pick up the learning rate. It's usually between 0.1, 0.01, up to you how you want the model to keep learning. Is it, we use 0.1 to accelerate it. So upon calculating this, and upon getting the W new, we do the following. We will calculate the new Z vector, and then use softmax on it, like the previous video. Get back to the previous video if you haven't watched it. And after softmax, we will see that our probabilities actually increased. As I told you, like y true here, for this case is 1 and 0, so the probability simply increased from 0.58 to 0.79. And this process keeps repeating the whole process for the two videos until you get the probability that you want, or until you stop training your model. Thank you for watching this video, and if you